Hello everyone, welcome to the session. Today I am going to start. I told you previously, according to our discussion, I will start from inorganic chemistry, right? In that section, the first chapter is atomic structure. So simply he is given atomic structure, but what he is thinking inside, the examiner point of view is that you have to learn the structure of atom. So in physical chemistry, you learn complete structure of an atom and evaluation of electrons and protons, neutrons and their electronic configurations, and many scientists has worked behind that, right? But in here, in the when coming to inorganic chemistry, what you will learn? Atomic structure means that is all about chemical periodicity. Understand? In basic manner, we will say periodic table, right? But in the standards, chemical periodicity. Why? Because our scientists has discovered that whatever the elements present in periods or groups, they can repeat their characteristics. Characteristics in the sense their properties, their properties. Whether they are physical properties or chemical properties, they are repeating from one to another. That's why they have given that name periodicity. According to periods and according to groups, they have a capacity to show their characteristics from one to another in a periodic manner. అంటే రిపీట్ అవుతాయి అన్నట్టు, ఓకేనా? సో మనం ఇందులో నేర్చుకోవాల్సిన పర్టికులర్ గా ఏంటి అని అంటే అటమిక్ స్ట్రక్చర్ లో. సో I'll give you that PDF also. I have written complete notes and I'll attach that all the pages after completion of the video. Okay. Whenever you see all those points, it will be very nice and crystal clear to you. ఓకే, మీరు చాలా బాగా దాన్ని అర్థం చేసుకోగలుగుతారు ఫస్ట్ ఆఫ్ ఆల్. సో మనం ఏం చదువుతాం? In a syllabus paper, I given just atomic structure, right? But in my notes, I have added another point, that is chemical periodicity. Okay, the first one is atomic structure. As per our discussion, the first inorganic chapter for set exam. It can haunt you until and unless you'll get a job. For example, you're writing any JL exam, PL, or any AP set. Okay, CSIR-NET, any competitive exam, IIT-JEE, okay, NEET, for example. And if you go for any exam which is belongs to chemistry, this chapter you must read. Why? Because they will give you the ionization energy, order of ionization energies, and what is that? Their reactivity orders. Okay, sizes, everything they can mugging up with this chapter only. So that's why you must learn atomic structure. Okay, atomic structure and chemical periodicity. Okay, already know that. If you see outline structure of periodic table, if it is a S block, okay, then D block will come in middle and P block will come afterwards, right? This is the outline structure of periodic table. And these two groups are, we will call that according to groups and periods only. We can't say that any is particular vertical column, horizontal row, this vertical column. We can't pronounce it like that. So therefore, what we can say, top to bottom in a group. Okay, these vertical columns we can pronunciate them as a top to bottom in a group, left to right in a period. Okay, this horizontal rows we can call them as a left to right in a period, right? If it is a S block elements, see, these two groups are S block and this is F block and this is P block and this is D block, right? How they given blocks? So many scientists has worked behind it. If you understand the complete periodic table, you will understand the beauty of chemistry. Why? Because ఏమంటారు, మన సైంటిస్ట్ వాళ్ళ హార్డ్ వర్క్ ఒక్కొక్కటి ఫర్ ఎగ్జాంపుల్ మీరు ఇట్లా పీరియడ్స్ ఇట్లా చదువుతూ ఉంటారు కదా, లెఫ్ట్ టు రైట్ పీరియడ్స్ అని చదువుతూ ఉంటారు కదా, టాప్ టు బాటమ్ అని గ్రూప్స్ చదువుతూ ఉంటారు కదా, ఇవి ఎట్లా డివైడ్ అయినాయి. So according to the principal quantum number, we will given the periods, right? The number of principal quantum number as increases, the number of periods increases. When the period number increases, number of shells increases. So how many electrons may be present in a shell? Those many elements are present in a period. సో అసలు చదువుతూ ఉంటే మనకి మైండ్ ఏమంటారు ఫుల్ రిఫ్రెష్ అయిపోతుంది అనమాట. వాళ్ళ హార్డ్ వర్క్ కి మన మైండ్ నిజంగా పోతుంది. నిజం చెప్పాలంటే ఎట్లా చేయగలిగారు ఇవన్నీ అని అన్నట్టు అనిపిస్తుంది. సో చాలా ఇష్టం నాకు ఈ చాప్టర్ అంటే, అండ్ చాలా ఈజీ కూడా. ఓకేనా, మీకు కూడా అంతే ఈజీగా చెప్తా. ఒకవేళ మీకు ఆల్రెడీ తెలుసు అని అనుకుంటే యూ కెన్ స్కిప్ ఇట్, యూ కెన్ ఫార్వర్డ్ ఇట్ అండ్ యూ కెన్ కీప్ ఇట్ ఇన్ ద ఫాస్ట్ ఫార్వర్డ్, యూ లిజన్ ఇట్. బట్ at the end of the video you don't miss the PDF. Understand? Okay. What I told you, 1, 2, 3, 4, 5, 6, 7. We have a 7 periods, right? 1, 2, 3, 4, 5, 6, 7. These are 7 periods, and 7 periods left to right. We can call them as a period. Okay. This period number is equal to principal quantum number. As the principal quantum number increases, number of shells increases. What is that? Number of shells increases. As number of shells increases, number of electrons increases, which they can added in the orbitals. Why? Because every shell has a suborbital, subshell. So in that subshell, they just divide it into S block, P block, D block and F block. For example, if you see the structure of an atom, if it is a structure of an atom, it have a protons and neutrons in the nucleus, and electrons can be revolve. They can rotate themselves and they can revolve around the nucleus, right? But initial లో ఎన్ని electrons ఉండాలనేది ఎట్లా తెలుస్తుంది? Okay, for example, first S shell is there. In S shell we have how many electrons? ఫస్ట్ షెల్ ఉంది కదా, దీన్ని ఫస్ట్ షెల్ అంటాం, లేదా దీన్ని K అని కూడా రిప్రజెంట్ చేయొచ్చు. అండ్ దిస్ ఇస్ ద సెకండ్ షెల్ ఆర్ Lth shell. Okay, and third shell and fourth shell, fifth shell also is there. And from fourth onwards, the shells which are coming, which are adding around the atom, they are adding to penultimate shell. Means they won't go forward. Okay, they will come backward. That's why we call them as a penultimate shell. After fourth period, it will come. Okay, so any ఈ shells లో particular గా ఒక ఆటమ్ లో ఒక షెల్ ఉంది అని అంటే ఎన్ని ఎలక్ట్రాన్స్ ఉండాలి? దట్ ఈస్ డిపెండింగ్ అపాన్ ద ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ ఆఫ్ ఎలిమెంట్స్. ఇఫ్ యూ సీ, we have a 118 elements in a periodic table, right? So 1, 2, 3, 4, 5, 6, 7, 8, like that we will count, right? In the first shell is denoting that first period. Okay, first period, how many elements are there? Just 2 elements are there. Then from where it is coming? From the first shell. How many electrons are there? Only 2 electrons. The first shell is consistence of S block, and S block is accommodated with 2 electrons. Got my point? And the second shell is consists of how many electrons? There are 8 electrons present in the second shell. So 4 already completed, right? Another 4 I am writing. How many electrons? There are 8 electrons. If you compare this to second period, there are 8 elements present in the second period. That is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. Are you got my point? See, so 8 electrons ekkada arrange chestaru in second shell. Second shell is consistence of S and P block elements, and S block consists of 2 electrons, and P block can accommodate with how many electrons? 6 electrons. So total how many are there? 8. Likewise the third shell, and third shell is consistence of S, P, D blocks, and S block can consist of 2 electrons, and P block 6 electrons, and D blocks how many electrons are present? 10. So total how many? 18 electrons. 18 electrons are present in a third shell, means you can check it in a third period. So why third period doesn't have 18 elements? Means third period doesn't consist of D block. Okay, it consists of S, P, D subshells they have, but D block is empty for third group. Understand? For third period. For third period, D block is empty. That's why we have to consider 8 electrons again. In the third period, we have 8 elements again. So what are those? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Again 8. If you check the first shell is, we can denote it like K or 1, no problem. L, M, N, all these are same. Okay, you can denote it like K, L, M, N or 1, 2, 3, 4. Any other you can call, no problem. Okay, how many shells, how many subshells are present? S, P, D, F, and F shell is doesn't fulfill, but up to D electron it can fulfill. Therefore 18 electrons are present, and 18 electrons are meaning to that 18 elements. So SPDF, okay na, SPDF subshells untai, but F shell won't fulfill. Therefore there are presence of SPD electrons only. They can accommodate 18 electrons in the fourth period. Therefore 18 elements are present in the fourth period. So what are those? Potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Understand? Up to 18 elements will be present in a fourth period. And after that fourth period, we can see the penultimate shell, and afterwards the sixth shell is anti-penultimate shell. Okay, they are not available for what is that? Forming bonds. So whatever the outermost electrons are present, those only are ready to form bonds. We can discuss all these points in the chemical periodicity, but what you have to learn from the periodic table means, firstly you should concentrate on a classification, the SPDF blocks. Okay, classification in the sense how they evaluated into blocks, and their electronic configuration. How could you say, how will you see that electronic configuration? If you see hydrogen atomic number is 1, helium is 2, lithium, beryllium, boron, carbon. Okay, approximately 6 elements we will look at it. 3, 4, 5, 6. Right. Okay. If you check the first element, that is hydrogen. Hydrogen have a 1 electron and 1 proton. Okay. Proton is with positive charge and electron is with negative density. Okay. Therefore 1 proton and 1 neutron. So the electronic configuration is, there is only one subshell, that is S block elements. So here only 1 electron present. The electron configuration of hydrogen is 1s1. 1 is mean to period number. Okay, and S is mean to subshell. Superscript is telling you that number of electrons, right? Therefore if you check the second element, that is helium. Helium consists of 2 electrons and 2 protons, right? And two electrons and 2 protons are present in only one shell. Okay, only one shell is present, right? In one shell we have only one subshell, that is S, and S can accommodate with 2 electrons. Therefore the electron configuration is 1s2. Okay, let's see the third one. This is the atomic number, nucleus, and it can accommodate with 2 shells. In the first shell there is a presence of 2 electrons, that is belongs to S, and in the second shell there is a presence of 2 subshells, that is S and P. So according to S, We have 2 electrons, and according to P, what is the number? 3. Therefore 1, 2, 3. So I forgot to tell you one thing. The electron number is equals to atomic number. Okay? Electron number is equals to atomic number. When the electron number is raising or electron number is decreasing, this is influences the effective nuclear charge. Okay, electron affinity, we will call that as electron affinity. So as the electron cloud is increasing in a nucleus, అంటే చూడండి ఇందులో నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ యాడ్ అవుతున్నప్పుడు ఎలక్ట్రాన్ క్లౌడ్ ఇంక్రీజ్ అవుతూ ఉంటుంది. సో మనం ఏం చేస్తాం, ఈ అవుటర్ మోస్ట్ షెల్ నుంచి ఒక ఎలక్ట్రాన్ తీసేయాల్సి వస్తే మనం యూజ్ చేసే ఎనర్జీని అయనైజేషన్ ఎనర్జీ అని అంటాం. సో ఎలక్ట్రాన్ అయితే తీసేస్తాం కానీ ప్రోటాన్ స్టిల్ ప్రెసెంట్ ఇన్ న్యూక్లియస్ కదా. సో దట్స్ వై ద న్యూక్లియర్ ఛార్జ్ అనేది ఇంక్రీజ్ అవుతూ ఉంటుంది, పెరిగిపోతూ ఉంటుంది. సో దానివల్ల ఏదైనా ఆటమ్ లో అవుటర్ మోస్ట్ షెల్ లో ఉన్న ఎలక్ట్రాన్ ని మనం తీసేయాలి అని అంటే ఇట్స్ నాట్ పాసిబుల్. వై? బికాస్ ద క్లౌడ్, ద పాజిటివ్ క్లౌడ్ విచ్ ఇస్ ప్రెసెంట్ ఇన్ ద ఆటమ్ internally they pulling electrons towards to it. Therefore the ionization energy gradual ga increase avutundi from left to right in a period. While discussing the trends I will tell you all these points. Okay, present I'm telling about the electronic configuration, right? So therefore you should concentrate upon that. So there is a presence of 2 electrons in S block, and P block lo n electrons unnai? Only 1 electron. So electron filling అనేది కూడా according to Hubble ఏమంటారు, షార్ట్ లోయెస్ట్ ఎనర్జీ లెవెల్ అనేది ఫస్ట్ ఫిల్ అయ్యి తర్వాత హైయెస్ట్ ఎనర్జీ లెవెల్ అనేది ఫిల్ అవుతుంది అనమాట. దేర్ ఫోర్ ఫస్ట్ సబ్షెల్ అనేది ఫిల్ అయిన తర్వాత, ఫస్ట్ ఎస్ సబ్షెల్ ఫిల్ అయిన తర్వాత మాత్రమే లోయెస్ట్ ఎనర్జీ నుంచి ఎనర్జీ పెరుగుతూ ఉంటుంది. ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ సీ దిస్ ఈస్ ద ఎనర్జీ ఆర్డర్, దిస్ ఈస్ ద ఎస్ బ్లాక్ అండ్ దిస్ ఈస్ ద పి, దేర్ ఫోర్ డి, దేర్ ఫోర్ ఎఫ్ విల్ కమ్. సో ఫ్రమ్ డౌన్ టు అప్ ఎనర్జీ ఇంక్రీజింగ్. సో ఎస్ బ్లాక్ అనేది చాలా లీస్ట్ ఎనర్జీ లెవెల్ ఉన్నట్టు అనమాట. సో ఫస్ట్ గా ఏమవుతుంది, ఎస్ బ్లాక్ లో ఎలక్ట్రాన్స్ ఫిల్ అయిన తర్వాత మాత్రమే పి బ్లాక్ వెళ్తుంది. అండ్ దేర్ ఫోర్ యూ కెన్ చెక్ ఇట్ బెరీలియం. ఓకే, సో ఇవన్నీ కూడా అంతే. బెరీలియం కి 4 ఎలక్ట్రాన్స్ ఉన్నాయి కాబట్టి 4 ఎలక్ట్రాన్స్ యాడ్ అవుతాయి. ఓకేనా, 3 ఎలక్ట్రాన్స్ 1 2 3 4. అండ్ ఫర్ ఎగ్జాంపుల్ బోరాన్ there are 5 electrons, 1 2 3 4 5, and carbon 6 electrons, 6 electrons. Cells are same, number of shells are not increasing in a second period, right? See what is the principal quantum number, can you tell the n number? That is 2. Why? Because how many shells are there? 1 2, only 2 shells only there, therefore the principal quantum number is 2. Understand? In 2 shells, how many subshells are there? There are presence of S and Sp. Okay, that is 1s2, 2 2s2, 2p1. ఇవి రెండు కూడా ఫస్ట్ గ్రూప్ లో ఉంటాయి కదా. నేను ఇందాక అవుట్లైన్ డయాగ్రామ్ వేసి చూపించాను కదా, అందులో ఎస్ బ్లాక్ ఎలిమెంట్స్ అనేవి ఈ వీటితో ఎండప్ అవుతాయి. ఓకేనా, నెక్స్ట్ మెయిన్ గ్రూప్ ఎలిమెంట్స్, పి బ్లాక్ ఎలిమెంట్స్ ఏవైతే ఉన్నాయో అంటే చూడండి, బెరిలియం ఇక్కడ వరకు ఎస్ బ్లాక్. ఆఫ్టర్ బోరాన్ పి బ్లాక్ ఎలిమెంట్స్ విల్ స్టార్ట్, రైట్? అంటే పి సబ్ షెల్ అనేది ఇక్కడ నుంచి స్టార్ట్ అవుతుంది. సో బోరాన్ కి ఫస్ట్ ఎలక్ట్రాన్ అనేది ఎక్కడ ఎండ్ అవుతుంది? పి బ్లాక్ లో ఎండ్ అవుతుంది. దేర్ ఫోర్ ఇట్ ఈస్ సో దట్ సైంటిస్ట్ హ్యాస్ కెప్ట్ దిస్ ఎలిమెంట్ ఇన్ ద పి బ్లాక్ ఎలిమెంట్స్. అండ్ కార్బన్, there are 2 elements in the P block, therefore P2, 2p2. But we have to mention the shell number also. Okay, don't forget that the principal quantum number is more important, and we can say angular momentum, that is L. Okay na, azimuthal quantum number అనేసి అంటారు. So according to azimuthal quantum number the L value is SSSP. Okay, S is 0, P is 1, D is 2 and F is 3. ఇది అజిముతల్ క్వాంటమ్ నంబర్. దీని గురించి నేను తర్వాత డిస్కస్ చేస్తాను. సో ఫస్ట్ ఏమవుతుంది, మనకి ప్రిన్సిపల్ క్వాంటమ్ నంబర్ అంటే ఏంటో తెలిసింది, షెల్స్ అంటే ఏంటో తెలిసినాయి, తర్వాత సబ్ షెల్స్ ఎట్లా ప్రెసెంట్ అవుతాయో తెలిసినాయి, అండ్ హౌ మెనీ ఎలక్ట్రాన్స్ ఆర్ గోయింగ్ టు ప్రెసెంట్ ఇన్ సబ్ షెల్స్ ఆల్సో వి ఫైండ్ దట్, రైట్? సో ఇంకా ఏం చూడొచ్చు ఇందులో, First shell we have S subshells. Okay, S orbital only. In second shell we have S and P orbitals. In third shell S, P, D. But the first electron is entering into S. Therefore, can you give me the electronic configuration? See first shell. First shell lo emundi S orbital undi. How many electrons unnai? 2. 1, 2. And later second shell. Second shell there is a accommodation with 2 subshells, right? That is S and P. And the principal quantum number is 2. 1s2, 2s2 to 8 electrons, right? 2 electrons from S and 6 electrons from P. There are 8 electrons. And next one is again, but what is the principal quantum number? 3 and S. Why? Because there is a lowest energy subshell, that is S, and we have only 1 electron. Do you got the electronic configuration of sodium? Likewise magnesium. For magnesium 2 electrons are present. Understand? Can you write the electronic configuration of aluminum? Another subshell is adding, that is P, and the first electron is entering into P block. Therefore, the aluminum belongs to P block elements. Got the point? So, from the left to right in a period, you can understand one point. Number of shells are not increasing, but the addition of electrons is increasing. That's why what we can say, from left to right in a period, the number of electrons is adding in one shell, that is creating some positive charge in a nucleus. Why? Because whenever the number of electrons is adding in one shell, the number of protons also adding in one nucleus. Therefore, the positive charge is increasing. So what this nucleus can do means, this positive charge is ready to pull the electrons which are present in outermost shell towards to the nucleus. Therefore, the outermost shells are being contracted with the nucleus. That's why from left to right in a period, the atomic size is decreasing. Understand? This is one of the biggest factor you must know in the trends. Okay, then how it works in left to from top to bottom in a period, we will see right now. There are 7 periods I told you previously, right? 1, 2, 3, 4, 5, 6, 7, 8. I written 8. Therefore, we can rub it, no problem, no issues. No one can stop. Halinaki, Robert, French, Cash, Ichard. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So, these are the A block elements. Sorry, S block elements. And S block elements, there is second group is there. This is the first group. And if you see second group beach, morning Carlo, Siri, Balu, Raju, Vella. Strontium, barium and radium. Okay. These are the S block elements. Complete. Finish అయిపోయింది కదా. And later what will start from fourth shell? There is a presence of d orbitals. సచిన్ యువరాజ్ ని లాగి పెట్టి కొడితే ఏసీ రూమ్ లో పడ్డాడు. ఓకే. అండ్ తిలోత్తమ జర్కిచ్చి హాఫ్ వేసి రూఫ్ ఎక్కింది. మనకి ఇంతవరకు ఇంపార్టెంట్. సో ఇవన్నీ పీ బ్లాక్ ఎలిమెంట్స్. అండ్ మిడిల్ there are many d block elements are present. You don't look at it. Okay, I'll rub it. Okay, if you see, these are the d block elements, right? And this is the 5th period, 6th period, 7th period. What is happening? From top to bottom in a group, whatever the number is increasing, if the number is increasing means n is increasing. N is increasing, n means principal quantum number. As the principal quantum number increases, number of shells increases. It depends. So therefore, for first period, 1 shell. For second period, 2 shells. For third period, 3 shells. For fourth period, 4th shell. For 5th, 6th, 7th, yes, there are further shells are adding. But how they are adding? They are ultimate or penultimate. Okay, they are penultimating. Why? Because they're coming inside. That's why we just subtract. So from here D block elements are present, right? We can call it as a n minus 1. N minus 1. Why? Because why we are doing n minus 1 ante 1 means from fourth shell onwards there is a presence of penultimate shell and which is ultimately adding inside. Therefore we have to subtract. Okay, n minus 1. Okay, n minus 1 chestam. N minus 1. So what is the nth number? Fourth. Okay, 4 minus 1. If we do 4 minus 1, what will come? 3. Therefore, fourth period, we will call it as a 3D series. And likewise, fifth period also. Okay, if you see, these elements belongs to S block, right? And these element belongs to P block. What I discussed previously, if you see from left to right in a period, there is no increment in the principal quantum number. That means number of shells are not constantly increasing. But what increasing? If it is a period 1, if it is a period 2, if it is a period 3. So period 3 means we have how many shells? 3 shells. Understand? In first shell, what is there? S orbital is there. In S orbital, there is a presence of 2 electrons. What is the electronic configuration of sodium? Sodium atomic number is 11, right? So 11 means we have atomic number is electron number. Already I told you, right? So if you see the electron number, there are 11 electrons in the total shells. So how many electrons present in a first shell? As first shell is consistence of only S subshell, so it can accommodate with 2 electrons. Later 6 electrons. Later 18 electrons. I told you, right? So in a P block, how many electrons are there? There are from S and P, which are present in the second shell. There are almost 8 electrons. Up to here 10 electrons completed. Okay. After one, this is the configuration of 11 electrons, right? Then where it can accommodate, that is entering into third shell and that is present in a S block again. So 5 minus 1 is 4. Again, we can call it as a fifth period elements like 4D series. Understand? See, from top to bottom in a group, as the number of shells is adding and number of electrons are also adding. See the magic, what will happen? This is 2 electrons and there is a presence of 2 and 6 electrons, and another there are ultimately presence of 2, 6, 8 and d electrons are also presenting, right? Therefore 10, and if you see we have to come again S block, right? In the next period we have to go for, what is that? We have to go for next shell. Next shell in the sense another 2 electrons are adding in another shell, right? Okay, outermost shell లో ఎన్ని ఎలక్ట్రాన్స్ అయితే ఉన్నాయో అన్ని ఎలిమెంట్స్ ఉంటాయి. ఆ పాయింట్ మీకు క్లియర్ కదా, చెప్పాను. నంబర్ ఆఫ్ షెల్స్ అనేవి ఇంక్రీజ్ అవుతూ ఉన్నప్పుడు, ప్రిన్సిపల్ క్వాంటమ్ నెంబర్ ఇంక్రీజ్ అవుతూ ఉన్నప్పుడు నంబర్ ఆఫ్ షెల్స్ అనేవి ఇంక్రీజ్ అవుతాయి అని చెప్పాను. సో పాయింట్ నెంబర్ 2 ఆల్సో క్లియర్. యాజ్ ద నంబర్ ఆఫ్ షెల్స్ ఇంక్రీజెస్, number of electrons are also gradually adding into the subshells. Therefore, the size of atom is increasing. So, how could you justify this point? As you go top to bottom in a group, the size is increasing. Why? Because the addition of number of shells. That means principal quantum number increasing and number of shells also increasing. Therefore, size increasing and shielding effect increasing. Okay, what we can say that right now, size and shielding effect both are directly relational to each other, directly proportional to each other. What we can say, no problem. You can say like that or like this. Okay, as size increasing, shielding effect is also increasing. Why? Because the electrons which are present in the outermost shell, they can shield by the electrons which are present in inside. అంటే ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఈ అవుటర్ మోస్ట్ షెల్ లో 18 ఎలక్ట్రాన్స్ ఉన్నాయని అనుకుందాం. ఓకే, మనకి ఈ షెల్ లో 6 ఎలక్ట్రాన్స్ అండ్ 2 ఎలక్ట్రాన్స్, టోటల్ 8 ఎలక్ట్రాన్స్ ప్రెసెంట్ అయి ఉన్నాయి కదా. ఇవి ఏం చేస్తాయి తెలుసా, ఈ న్యూక్లియస్ వైపు పుల్ అవ్వకుండా, న్యూక్లియస్ దాన్ని పుల్ చేయకుండా ఈ లోపల ఉన్న ఈ 2 ఎలక్ట్రాన్స్ అనేవి షీల్డ్ చేస్తూ ఉంటాయి. అంటే దేర్ ఈస్ ద ఆపోజిట్ ఫోర్స్ యాక్టింగ్ ఆన్ దిస్ షెల్, acting on this electrons which are present in outermost electrons. Therefore, the outermost electrons are not easy, don't get disturbed. So top to bottom group lo number of shells అనేవి ఎట్లయితే ఇంక్రీజ్ అవుతున్నాయి, ఫస్ట్ షెల్, సెకండ్ షెల్, థర్డ్ షెల్, ఫోర్త్ షెల్, how they are increasing, and the electrons also gradually adding to that shells, and whatever the electrons has been added in the outermost shell, they can be shielded by the inner electrons which are present in the inner shells. Therefore, the distance between nucleon to outermost energy shell is very high. So the electrons which are present in the the electrons which are present in the outermost electronic shell, they can't come to nucleus. Nucleus unable to pull that electrons. Okay, ఈ electrons ని pull చేయలేదు. Why? Because there are inside some electrons are present. So there is a opposite force is acting, that is called shielding effect by this inner electrons. Understand? Therefore, the outermost electron shell are facing less ionization enthalpy. అంటే ఒక ఎలక్ట్రాన్ ని అవుటర్ మోస్ట్ షెల్ నుంచి మనం తీసేయడానికి, రిమూవ్ చేయడానికి యూజ్ చేసే ఎనర్జీని అయనైజేషన్ ఎనర్జీ అని అంటారు, లేదా అయనైజేషన్ ఎంథాల్పీ అని అంటారు. సో ఈ అయనైజేషన్ ఎంథాల్పీ అనేది కూడా సైజ్ ఫ్యాక్టర్ మీద డిపెండ్ అయి ఉంటుంది. ఓకేనా, టాప్ టు బాటమ్ size increases and left to right size decreases. Why? Because left to right number of electrons are adding in same shell, therefore size decreasing. But top to bottom in a group number of shells increasing, therefore size increasing. And shielding effect increasing. Why? Because as the number of shells increasing and they facing some repulsive force from electrons which are present in the inside the nucleus. Okay, అంటే న్యూక్లియస్ కి అవుటర్ మోస్ట్ షెల్ కి మధ్యలో కొన్ని షెల్స్ ఉంటాయి, అవి ఒక ఫోర్స్ ని యాక్ట్ చేస్తూ ఉంటాయి అనమాట. సో దాన్ని రిపల్సివ్ ఫోర్స్ అంటారు, దాన్ని షీల్డింగ్ ఎఫెక్ట్ అని చెప్పేసి అంటారు. సో అది కూడా ఇంక్రీజ్ అవుతుంది. యాజ్ ద నంబర్ ఆఫ్ షెల్స్ ఇంక్రీజింగ్, size increasing and basicity also increasing. This is the most important point. Why? Because basicity is directly proportional to metallic character. Remember this point. Okay, metallic character is directly proportional to basicity. They both are increased gradually. Okay, as size decreasing, basic character decreasing and aesthetic character increasing. Therefore, left to right in a period, aesthetic character increases. Therefore, they wants to form bonds with covalent character. We will discuss this all these points in the chemical bonds. So most important గా నేర్చుకోవాల్సింది ఏంటి అని అంటే క్లాసిఫికేషన్. ఓకేనా, ఎవల్యూషన్ ఆఫ్ atom and evolution of electronic configuration and their atomic number, how they are increasing left to right in a period and top to bottom in a group. So therefore their size, ionization enthalpy, and all these are trends. I'm discussing about trends. Electron gain enthalpy. Okay, effective nuclear charge, or electron affinity. Okay, and metallic character. So all these points you have to learn from first periodic table. I have given all these points in the notes and I'll add that notes also. You can quickly learn. Okay, I just discussed all the points like what is that, how once you check the PDF you will understand everything. The first trend is what you have to learn from the chemical periodicity. The first trend is ionic radii. Okay, later atomic radii or radius.